Hello everybody, I'm Alexei Kraber, the organizer of SF Spark and SF Hadoop, and here we're at Uber Engineering. For the very first time, we have this first joint meetup of SF Spark and SF Hadoop. And we also have Cassandra, SF Cassandra meetup, which actually initiated this great gathering. And we have with us Spitzer, who talked about Spark Cassandra connector. Welcome, Russ. I think Spark is super hot. Cassandra is very often used in this smack stack combination which we discussed earlier, and I just want to find out, how did you come to do this Spark connector, and what role it plays in your life, right? What are the most interesting things about it?
I have been working at DataStax for about 4 years now, and we all kind of got introduced to Spark around Spark 09, which was the dark ages of Spark. One of my co-workers, the team lead on the DataStax analytics team, Piotr, he basically churned out a Spark Cassandra connector prototype in about 2 weeks. And he brought it to all of us, and we were like, wait, all of our Hive integration, all of our Hadoop integration, all of our Pig integration looks terrible compared to this. This is so much easier to explain, so much easier to work with. And it started solving a ton of problems that we had in Cassandra. At the time, one of the issues is, how do I move a whole lot of data from one Cassandra table to another? I have different partition keys. I changed my schema. I need to do some big change. And all of a sudden, we had this really easy syntax for moving a whole lot of data around and having all of the hard stuff like splitting up your data, batching together stuff on writing, all of that happening efficiently and automatically and with this data locality. I mean, it was great. It's a great experience.
So I think this is the first time we have Cassandra in kind of the SF Spark meetup, right? So generally, we have a lot of folks not familiar with Cassandra. So obviously, one of the questions with distributed systems data locality, right? So you have basically now like multiple beasts distributed on the same machine. So you have basically Spark sitting on the same cluster, Cassandra sitting on the same cluster, they're all talking to each other using their own protocols. Can you kind of briefly outline how do they interact, and do they take advantage of the fact that some data in some RDD or partition is collocated with some node where Cassandra is supposed to have the same data?
Yeah, so that was one of the key things that we liked about Spark when we were looking at it originally, is that you're allowed to specify with every section of data that gets read out of some system exactly where you think it is. And because of that, you can give priority to certain machines for reading that section of data. So basically, we take the token range that has all of the Cassandra data, and we ask Cassandra, where are these tokens owned? What ranges exist on what machines? And then we tie that together with the Spark executor IDs and try to match them up. So when you actually say, I'd like to read this whole table out of Cassandra into my Spark RDD, it's going to try its best to make sure that it reads the portions of data that exist on the same machine that Spark is running on. This is, of course, just one way of doing things. If you want to run it on a completely separate cluster, it'll still work. We actually use the Cassandra Java driver underneath to actually communicate all the data back and forth. So all of those same benefits you have with query routing and all that kind of stuff comes into play. You just don't get the data locality if you're not running in the same cluster.
Super cool, super cool. So, and in terms of DevOps, right? So basically, we have these big clusters. How do people typically manage, both Cassandra and Spark in practice? What do you see?
That's a bit of a hard one. I mean, so there are three main resource managers for Spark right now. There's Yarn, Mesos, and the standalone manager. And I think, I didn't check the latest Databricks survey, but I'm pretty sure standalone is still the most popular of those three. And with the standalone cluster manager, with each of those resource managers, you basically have a different avenue of monitoring. You have to add monitoring in a different way. Within our product, within DataStax Enterprise, we have that all synced up with our Ops Center client, which is our universal monitoring tool. If you work with something else, you basically have to hook in your own stuff. But Spark comes built in with hooks for Grafana and, basically any kind of CodeHail metrics accepting sync that you got.
Yes.
So basically, people do a whole variety of things. Our customers are mainly using Ops Center and the standalone Spark Manager context that it automatically makes its own website when you start it up. So people use that. But outside of that, I think a lot of people are hooking into the various metric systems with Grafana and things like that.
Do you see a lot of people using Mesosphere? Because I've seen basically you can launch Cassandra and Spark on it.
Yeah, I mean, so I don't get to interact with those people as much as I'd like to, but there are a lot of Mesos users out there. It tends to be easier to work with than the Hadoop crowd because they tend to have Hadoop is Java application. We end up having lots of class pass issues. Mesos tends to be a little bit cleaner in that regards. But I don't know too much about what those people are using.
Cool. I mean, Cassandra is interesting. Like we've seen examples in a startup, right, using a kind of dating app and kind of peak time. So can you kind of briefly explain, like, what are the strong cases for Cassandra? Like, what are among your use cases? Where do you see like people most succeed with it, and which of these people use Spark? Like, what's the typical good strong combination?
So, I guess I can start out. Most of our base users are people who have some kind of big data problem, something where they know their questions. Their question is asked very repeatedly, very often, but over a small set of their data at random times. So basically, the OLTP dream, right? I've got a very easy query, but I have to ask it a ton of times, and I need it never to have a high latency. It always needs to respond quickly. So we see a lot of things where you have tracking of customer events, things like that, where you have tons and tons of incoming things, and every once in a while you need to get like the last 5.
Right.
Or you need to analyze all the information for just one customer. Where Spark starts coming in is where we start having people say, well, I've been running my regular application for all this time, I have this great customer-facing thing, but now internally, I want to make some business decisions based on all of my data in aggregate. And that's where Spark comes into play, because Cassandra doesn't actually have a lot of great tools for saying, I'd like to do this bulk operation on everything that I've learned so far. Spark basically says, well, that's all I'm built for. I'm built for looking at everything in conjunction, doing these large shuffles, being able to join all of your data together. I mean, it's one of the things that people come to Spark for is like, well, I've got all this Cassandra data from these 2 giant tables, and I'd like to join them. And doing a several terabyte join is not a problem for Spark.
Yes.
Spark can just do that.
Yes.
So you start getting there. And then the newest thing, which is actually really interesting, is a lot of people are bringing streaming into it. So people will have some kind of messaging bus or messaging queue, and they want to have that go into Cassandra, but also compute aggregates and have those aggregates stored at the same time in Cassandra. So basically, they'll have their incoming data go into this system, compute a bunch of sub-aggregates, have those stored to Cassandra, and then serve those sub-aggregates out of Cassandra. So their reading of their aggregates is very, very quick, but the aggregate processing can be done with a more bulky machinery.
Right. So it's kind of, you get like another interesting take on Lambda architecture, because you can use Spark and then load it into Cassandra and then serve it from Cassandra back.
Yep. Yeah, I mean, isn't that everyone's goal, right? Everyone wants everything.
Yes.
You want to be able to handle your high latency, your low latency, your high volume, your low volume, all in the same system and have it all kind of behave the right way.
Yes.
And it's still very difficult, but we're getting a lot closer, I think, now than we were, 5 years ago.
So you mentioned OLTP case and you mentioned batch case, and it reminds me, our common friend Evan Chan is doing PhyloDB, which seems like it's serving both cases. I just wonder, like, what do you think of this?
Oh, I mean, I love PhyloDB, and I of course love Evan. It's a really cool idea. It's basically, the idea of using all of the cool Cassandra elements that exist and fitting a slightly higher latency query system onto it, where you basically are able to access huge amounts of data that have been kind of pre-organized into a very quick to access format. So it's a really cool idea. It's really nice, and I really hope we can get some more customers using it. I only know a few people who are trying to use it in production right now, but I hope that increases.
Yeah, we had Evan, speak at Scala by the Bay, and from his, I think, current vantage point, I think we'll see much more usage of it. So I'm really looking forward to kind of that variation of Spark Cassandra interaction. Cool. So, and what's next for the Spark connector?
Oh man, what's next for the Spark connector? So, I mean, one of our big issues is that the Spark project itself changes APIs on what seems like a daily basis. So we're almost always playing catch up with the Spark project, but it's pretty clear right now that the future of Spark is structured data sets.
Yes.
The dataset API, you have a schema on everything that goes in, and you have the ability to optimize and deal with things in memory that have been unserialized. It's really great. So we're trying to look at the Spark Cassandra connector, and a lot of our interfaces right now don't have direct translations into the data frames API. So we're trying to figure out how we can make that work. So, so for example, there's something I'm really interested in, which is basically a direct join, where you take an RDD of partition keys and you pull them all out of Cassandra at once. So inside of the Spark Cassandra connector, we have an API for this called Join with Cassandra table. Unfortunately, the current design of Catalyst doesn't have that concept. Basically, it would have to read the entire table into memory and then do a join within Spark. So we're trying to figure out ways to kind of get those kind of ideas into Spark proper. Because obviously that's not something that just applies to Cassandra.
Right.
You can imagine tons of even RDBMSs where you would benefit from only taking the subset of items that you want out of the database, rather than pulling the entire database in and then chopping it up.
It's like Parquet, right? Like Parquet. Like you basically want to make Spark datasets and play nicely with other distributed systems.
Yeah, so I mean, Parquet has already got a lot of this stuff nicely baked into Spark, because within Parquet, we can basically say within this file, values between this and this exist. Here are some summary statistics. The problem with us and with other hash partition-based stores like React and things like that is that we don't know exactly what values are there. We only know what range of hashes of values are there. So the mapping isn't direct. So we need a better interface that lets us express to Spark, like we do in the RDDs actually, and tell it that there is an underlying partitioning here. It's not monotonic on the values of the keys, but it exists, and you can take advantage of that. Things like that.
Interesting. Interesting. So so that seems like that would be nice for like many players in the space to collaborate. And this Mac Stack will be on the better for this.
I hope so.
All right. Well, thank you very much for coming. It was
you.
a great talk, and surely we'll have you back, in all these meetups.
All right.
Thank you.
Well.